All right, we are going to cover 3.4, which is more properties of logarithms. And we're going to focus on these three properties, and then there's the inverse property that we actually mentioned a little bit in the previous lesson. But basically, the product rule for logarithms says that if I have the log of A plus the log of B, that actually becomes the log of A times B. Okay, so if I add logs together, it's the same as doing the log of one thing times the other thing. The quotient rule is the opposite. If I do the log of A minus the log of B, that would be the same as if I did the log of A divided by B. And, one way that might help you remember this is logarithms are very much related to exponents, right? And if I have two powers that are being divided, we actually subtract the exponents. And if I have two powers that are being multiplied, I add the exponents. Okay, the last thing is the power rule. And the power rule says that if I have the log of a power, I can take that exponent and move it to the front. This is the same as A times the log of B. Okay, so let's put these properties into practice. So the first set of examples says to expand each logarithm. So this says natural log of 9y. Well, that's 9 times y, so I can write that as a natural log of 9 plus the natural log of y. All right, let's try example 2. I have the log of the square root of x divided by y to the 5th. So that's a quotient, so I can write that as 2 logs. That's the log of the square root of x minus the log of y to the 5th. Now I can actually continue this because these are both powers. Now you might say, hold on, Miss Jackson, there's not an exponent here, but there actually is because square root of x is the same as x to the 1/2. So I can write this as 1/2 log x minus 5 log y. Okay, example 3 is just putting the power rule into practice. I can write that as -2 log base 2 of x. Should have done these in alternating colors. I suppose it's not too late. I'll do this one in purple. Okay, this is a product, log of x times y cubed. So this is going to become log of x plus log of y cubed. But I can keep going because this is the log of a power. So this is log x plus 3 log y. Okay, last one here in this row. Again, I have a product. So this is the log of 1,000 plus the log of x to the 4th. And I can keep going. So log of 1,000 is something that I can evaluate. 10 to what power is 1,000? 3. And that, I'm going to bring the 4 down into the front. Okay, why don't you go ahead and pause the video and see if you can try examples 6 and 7. So just give it a try, and then when you have them done, return to the video and we'll talk through them. All right, let's walk through these. So this is a power, so I split all of them up into 3 separate logs, and then the last thing is I moved that exponent out to the front. Sorry about my scribbles here with this one, but This is a quotient, so I can split it up into subtraction. So this becomes the natural log of square root of x squared plus 5 minus natural log x. Last thing I can do here is this is all being raised to the 1/2 power, so I can move that 1/2 to the front. And that is it. All right, now we're going to go the opposite way. Write each expression as a single logarithm. So example 8 says I have log x plus log 5, which just becomes the log of not x plus 5, but x times 5, log of 5x. Natural log x minus natural log y doesn't become natural log, I gotta do it fancy, natural log of x divided by y. Okay, 1/5 log z is the same as if I have z to the 1/5, or I could write it as the 5th root of z. Either way is fine. Okay, example 11, I can do a couple things. That 4 can go in the log and become log of y to the 4th, but I'm also subtracting log z, so this is going to become the log of y to the 4th divided by z. Okay, let's see here. For example 12, I can move this and this into the log. So I'm going to have the natural log of x cubed y all cubed plus the natural log of y z squared squared. So that gives me x to the 9th, y to the 3rd, and that gives me y squared z to the 4th. And then I can combine these together. And when I combine these together, I'm going to multiply them. So I have x to the 9th times y to the 3rd times y to the 2nd becomes y to the 5th times z to the 4th. Okay, this one here, I have natural log of x to the 5th minus natural log of x squared y squared. And since I'm subtracting the logs, I'm going to divide them. So this becomes x to the 5th over x squared y squared. And the last thing I can do is I can simplify those x's. So it becomes x cubed over y squared. Okay, so that's logarithms. All right, in the last lesson, we talked about how logs and powers are inverses of each other. So let's actually explore this a little bit more. So let's say I have log base 2 of 2 to the 3rd. Well, 2 to the 3rd is 8. And log base 2 of 8 means I'm looking for 2 to what power is 8? And the answer to that is 3. Okay, now let's try this one. 3 to the log base 3 of 9. Log base 3 of 9 asks 3 to what power is 9? And the answer is 2. And 3 squared is 9. So what I want you to notice is that in both cases, the answer was, the number that's we're taking the log of or that's in the exponent. As long as the bases are the same, that number will be the answer. Okay, so if I have, log base b of b to the x, so that's like this example here, my answer is just going to be x. And the opposite is true. So if I have b to log base b of x, then my answer is just x. So they cancel each other out. They are inverses of each other. All right, so a couple really quick examples just to illustrate this point. So if I have log base 6 of 6 to the 5y, this is literally just 5y. 7 to the log base 7 of 4x is just 4x. Okay, natural log. Natural log, remember, is log base e. So log base e of 12, log base e of e to the 12 is 12. Okay, 10 to the log of 7.3, that is base 10, so this is 7.3. And that's 15, and that's 3x plus 1. So they undo each other. Another way to think about it, is with our power rule, right? If I have natural log of e to the 12th, I can say that's 12 times natural log of e. Well, what's natural log of e? This asks e to what power is e? Well, that's 1. And 12 times 1 is 12. So, all that to say, logs and exponentials undo each other. So you are going to work on the 3.4 homework, which is on pages 13, just page 13. And we will do our final lesson tomorrow.